Hello and welcome back. This video will cover the start of section 1.2, and this section looks at types of data. So in this video we'll talk about three different ways of comparing different types of data. The first comparison that we'll make is the difference between parameters and statistics. So a parameter is simply going to be a numerical measurement of a population, of an entire population. And a statistic is going to be a numerical measurement of a sample. So one way to remember this is that parameter and population both start with P, and statistic and sample both start with S. And typically, we will not know a parameter because we're not going to know everything about a population sort of in general. Whereas we will use statistics, as in individual statistics about specific samples, to try to estimate a parameter. So for instance, if we wanted to know about the average height of all Americans, the average height of all Americans will be a parameter, because this is referring to an entire population. Whereas if we were to take a sample of 500 Americans, the average height of these 500 Americans will be a statistic. This is a numerical measurement of a sample, a sample of 500 people rather than of every single American. And often we will use the statistic to estimate the parameter. Next, we'll look at quantitative versus categorical data. So quantitative data is also called numerical data, and it uses numbers to represent measurements. And these numbers will correspond to an amount of something. So they're trying to quantify some amount. Whereas categorical data, also known as qualitative or attributive data, is going to use names or labels. Now, these names or labels could involve numbers, so you have to be a little bit careful when coming up to determining something as quantitative or categorical. So, for example, height is going to be quantitative because this is describing an amount of something. Essentially, how tall are you is going to describe, say, either an amount of feet or meters or something like this. Points scored in a game, this is going to be quantitative because it's describing an amount of something, an amount of points. And then the year that someone was born, this is also going to be quantitative. We're just assigning each year a number, and this number means something. The year 2000 comes before the year 2001. So even though this doesn't describe specifically an amount of something, we are measuring the passage of time using numbers. However, if you were to look at someone's name or someone's nationality, this is going to be categorical. You're not going to use numbers to represent these things, so clearly it's going to be categorical. However, a jersey number is still a number, so we might be tempted to say quantitative, but that jersey number doesn't represent an amount of something. It doesn't give us any more information. It's just a label that we've assigned to that player. It doesn't mean anything beyond anything just like a name. This is all a jersey number is. So this is going to be a categorical type of data. And one thing to keep in mind is that when we're looking at quantitative data, we have to include units, or at least describe what that number represents. A jersey number, it's not going to be 23 anything. It's just a name 23. Whereas if I were to describe a height of someone, I need to include units. Am I measuring someone in feet or in meters? As far as a year, I'd have to indicate that the number that I'm writing down is not going to be 2000 something, but it's going to represent a point in time. So I'd say the year 2000. The last type of data that we'll look at is going to be discrete versus continuous, which I think is the easiest one to mix up. So please be careful when you're trying this in the homework. Discrete data is quantitative, and continuous data is also quantitative. So they're both corresponding to numbers. But discrete data corresponds to data that essentially we can count, or we can count something. And continuous data is specifically not countable. And I think one of the best ways to see this is to look at a couple of examples. So, for instance, if we were to look at the number of players on a team, we would essentially count how many players there are. So we are counting something, so this is going to be discrete. And likewise, if you look at points scored in a game, this is also going to be discrete. One thing to sort of keep in mind, one easy way to check is that you can always talk about the next number when you're talking about discrete data. If there are 12 players on a team, the next bigger team that you could construct would have 13 players on a team. So if you scored 27 points in a game, the next amount of points you could score is 28. There's always a next number in a discrete list. Whereas continuous data, like height, there is no next data point. So this will be continuous. And one way to sort of think about this is, if I were 6 foot, I could. If I was going to measure myself, I might be 6 foot. I might be 6'1", but I could also be anything in between. I could be 6.5. I could be 6'1/4". I could be any number in between. There exists a continuum on which you can measure yourself. There is no next height. And this last one is maybe the trickiest one. When we take an average, this number can exist on a continuum as well. So this is also going to be continuous. Even though the points you score in a game is clearly discrete, the average number of points you score is going to exist on a continuum. Maybe I score on average 10 points a game, but on average maybe I score 10.5 points a game. Maybe on average I would score 9 3/4 points in a game. When you take averages, things become a little bit more continuous, and there is no next number in line after this. And then on a quick note, I'll mention the difference between two words, fewer versus less. I know this came up in Game of Thrones, so maybe some of you will already have this pointed out. But we use less and fewer in different situations. Fewer is used for discrete data. I scored fewer points in a game than my teammate, and less is going to be used for continuous. So any time that you're describing, say, height or something like this, you'd use the word less. Fewer corresponds to individual things, and individual things are going to be discrete because we can count them. When we're on a continuum, we'll use less. And I'll stop there.